All right, in this tutorial I'm going to go over how we can sort of plot this data in Logger Pro, and then what we're going to do with it to try to figure out what the relationship is between the mass that we hung from the spring and the period that we measured. So this is all the data that we collected last time. You should have this. You should also have Logger Pro installed. So I'm going to just open Logger Pro. And we'll get a screen like this. I'm also just going to find the document that we used to go over this. So where's our class? Here we are. And it was in here. And it was called Baby Bouncer. Okay, so this is what we wrote up last time. And we need a graph of our raw data pasted in here. So what I'm going to do is go back to the spreadsheet, and I'm going to take the mass and copy that into here, and then I'm going to take the period and I'm going to copy that and I'm going to paste that here. And then I'm just going to fix my headings here by double clicking, and I'll change this heading to mass suspended from spring and give it the short name M, and the units are kilograms. Done. And then I'm going to call this one period, and the short name for period is capital T, and the units was seconds. Done. Okay, and all the data is now collected in the bottom corner here. I want it to take up as much space as possible so I can see what's going on. So I'm going to click this auto scale button in the top here, and you'll see that it scales it so that the data fills the graph, but we've lost our 0. So I'm just going to click on this lowest value and change that to 0, and then I'm going to click on this lowest value and change that to 0, because it's much easier to see what's going on if we can see the origin. So it looks almost linear, but it's kind of curving a little bit. And this is typical of a square root relationship. And we can check that by going Analyze, choosing Curve Fit, and then choosing a square. Is there a square root? No, we might have to just choose a power. So we'll choose a power relationship, and we'll try that. And you can see that fits reasonably nicely. So I'm just going to have that curve on there without much explanation, and then I'm going to, and you can see that the power is almost 0.5, and if we raise something to the power of a half, that's the same thing as square rooting it, sorry. Okay, and then I'm just going to give it a title. So I just double clicked on the graph, and then I'm going to give it the title graph of period versus mass. Done. Okay, and now I can take this graph and just copy it, click Control C. So in order for that to be selected, you need to be able to see these little boxes in the corners. And then I can paste that into my report here. And there's my graph. Okay, so it didn't quite fit on that page, so I might just take the heading and hit Enter. And I also need to paste in the actual data that I used to produce that graph. So I'm just going to do this. I'm going to add some borders by clicking on this borders button. There we go. And then we'll copy that and we'll paste it in here. I'll paste it unlinked in case I make some silly changes later on. So there's our raw data. There's our graph of the raw data. And then it says state the relationship indicated by the shape of the graph of the raw data. And we can say that this looks like a square root relationship. We'll go over how to identify these relationships from the shape of the graph once we finish this sample. And then this will hopefully make a little bit more sense when we go back over it. So we can say this graph shows that the relationship between the period and the mass appears to be a square root relationship. Okay, a square root relationship basically looks like a sideways parabola. Okay, so we need to be able to recognize certain relationships. Okay. The next thing is that we then need to transform our data. And because we've identified that this is a square root relationship, we then know that in order to make this into a straight line, which is our next job, we're going to need to square root whatever we have on our horizontal axis here. So if it's a square root relationship, we're going to square root the mass. If it had turned out to be a square relationship, then we would have taken the square of the mass. So we're now going to go back to our data table here, and I'm actually going to create a new sheet here. So if you click the little plus on the bottom and create a new sheet, and we can call this is the transformed data. So I'm just going to rename this transformed data, and I'll call it, just so it's easy for me to see what's going on, I'm just going to call this raw data. Okay, so for our transformed data, we're going to want to have the first row is going to be the square root of mass, and the units for that is going to be square root kilograms. And writing square root symbols is a bit annoying, so I'm just going to write SQRT kg. Okay, and then we're going to want our uncertainty in square root of mass, and that's also going to be in square root kilograms. And then in our third column, we're going to want to just copy over the period data. So the only thing we need to change is the mass. So this is just going to be period. Oops, I should have the units here. So period in seconds, and this is going to be uncertainty in period in seconds. Okay, so now I can copy over the data for the period. So I'll do that first because that's uncomplicated. So I'll take all of this and just Control C. And then I'll paste that in here, and that just disappeared. Oops, actually, sorry. No, so what I need to do to paste it is right click, and I'll go paste special, and I'll paste values only. So then it'll paste the actual information. It might lose your nice rounding. So I'm going to re-round all of these. I'll round these back to, whoops, to one significant figure. Actually, not quite. So now those are correct. This one still needs one fewer. This one needs one fewer. This one needs one fewer. And these ones, this one should be only 2. These ones should be to 3. And these ones should be to 2. Should they? I'm just going to increase that one. Yep, no, that's right. Okay, so there's my period data. I've lost a bit of... Okay, if you double click on the border between two columns, it'll automatically resize them to fit whatever's there. But I might actually... Yeah, that should still fit on a page. So square root of mass, we're going to type equals and then write SQRT, and then open a bracket, and now we want to go back to this raw data sheet, and we're just going to select the first mass here, so 0.05, and then close the bracket and then hit enter, and that'll now work out the square root of whatever was in that cell. So what I entered there was square root, and then I clicked back here and chose the right cell, and then I hit enter, and then I can auto-complete that, and it'll square root whatever's below the first cell that I square rooted. And so that now gives me all of the square roots of all the masses. Now for the uncertainty in the square root of mass, this is a bit tricky, and we're going to spend a lesson explaining how to do this. But I'm just going to show you how you would do that in this case in here. So the uncertainty in the square root of the mass is going to be equal to I'll just show you how to do it because it's kind of complicated to explain, and you can just copy me for now. So we're going to go back here, and we're going to take the uncertainty in the mass, and we're going to then divide by, so that's a forward slash, that's divide by the mass. And that tells me what percentage of uncertainty I had. And because I've square rooted, which is raising it to a half, I'm going to multiply that by 0.5. As I say, you won't understand all of this at this stage, but we will go over how I got to here later on. And then I'm going to go back to here, and I'm then going to click back in there, and I'm going to multiply that whole thing by the square root of the mass. Okay? So you can go back over that. You can go back in the video and just watch how I did that, and just check that you end up with the same answer here. And now, having done that complicated thing for one row, thankfully I don't need to do it for all the other ones because I can just auto-complete them. Okay, and now I want to do that rounding thing again because these should only be to one significant figure. And they are all in the third decimal place, which is convenient. And I'll do the same with this one. So now they are all to 3 decimal places. These are all one significant figure, and these are rounded to the same number of decimal places. So now that transformation of the data is complete. I can just place some boundaries around this, or borders, and then copy that whole table into my report, which was here. Okay. And I'll paste that unlinked so that if I make changes, it's not going to mess it up. Okay, and now we want to graph this data. Okay, this is the complicated graphing part. So this is going to take a little while, but this is the last thing that we're going to do today, and we'll talk about conclusion and things next time. So to graph this data, we're going to create a new graph here. I'm not going to bother to save this, and I'm going to now paste in my values that I've just got from my transformed stuff here. So I'm going to get my square root of mass, and I'm going to plot that into the X column here. I'm going to get my period and plot that into the Y column here. And then I'm going to resize it, and that looks fairly linear, which is what we were hoping for. I'm going to then change it so that 0, 0 is in the graph again. Okay, and then I'm going to change the names of these. This is the square root of mass. And the units are square root kilograms. Done. And my Y values were the period, T in seconds. Oops, lowercase s. Done. Okay, so the next thing is I want to plot my uncertainties on this graph because they're going to become quite important. So I'm going to go to data and choose new manual column, and I'm going to call this uncertainty in square root mass, and I'll call it U square root mass, and this is going to be in square root kilograms as well. And then I'm going to create one new manual column for the period as well, uncertainty in period, UT, and that's going to be in seconds. Done. Alright, now I'm going to take that information from my data table here. So uncertainty in square root of mass was this stuff. And I'll paste that in here. And uncertainty in period was this stuff. And I'll paste that in here. Okay, and now I'm going to double click on square root m. And I'm going to choose options. And I'm going to use, to get it to create error bars for me, I'm going to tick error bar calculations, tick use column, and I'm going to use uncertainty in square root of mass. Done. And we'll see these little horizontal error bars that tells us sort of how accurate our information was. I'm going to do the same thing with period. Double click, choose options, tick error bar calculations, use column, and we're going to use the uncertainty in period. So now we have vertical and horizontal error bars. I'm going to just double click and get rid of the point symbols because those circles are quite distracting. So if I get rid of that, those circles will disappear. And I'll also, while I'm here, add a title. So this is transformed, or we'll call it linear graph. No, we won't. We'll give it a more specific name. So we'll say period versus square root mass. That makes more sense. Done. Okay, so now we have the points plotted with a sense of how much they could vary. The next step is to add a linear fit, and we can do that quite quickly by just clicking up here on linear fit. And that gives us the best straight line through our data. You can see we have one outlier here, and it's an outlier because the line doesn't go through the error bar. But most of the points are pretty good. And then the next step is we want to create error lines. So this is going to be the last step for today. So we'll go to Analyze, and we'll choose Curve Fit. And what we want are two lines now that are going to be, one that's going to be as steep as possible and still go through most of the error bars, and one that's going to be as flat as possible and still go through most of the error bars. So I'm going to scroll up here and choose Linear, and then try Fit, and then change to Manual. That'll allow me to customize it a little bit. And click OK. Alright, so this is now the new line that I added, and it's exactly the same as the other because it was plotted in the same way. But if I double click on this, I can change its appearance first so that it's a different color. That'll make it easier to see what's going on. So I'll make this one blue, and I'll tick Enable Line Drag. Okay, so now we have this blue line here with these little diamonds. And what I can do, I'm going to make this one as flat as possible. So I'm just going to drag this lowest diamond upwards and the highest diamond downwards a little bit. And it's okay if you miss sort of one, or if you've got 7 points, it's okay if you don't go through every single point, but you want this line to still go through most of the points, but to be as flat as possible while still going through those points. So this is going to be my minimum gradient line because it's the flattest possible line that still sort of fits our data quite well. And I'm using the size of the error bars here to guide me. So I'm going to let this line miss the top point and this outlier, but go through every single one of the other points. Okay, so that looks like a decent sort of fit for the data. So that's my first error line. And then I'm going to, just so that I don't screw it up, I'm going to double click on that and turn off the error line drag. Okay, so we've now plotted a line of best fit. The information about that line is in this black box. And we've plotted an error line, and the information about that is in this box. So now this transformed graph is complete. I'm going to copy that into my report and just check that you've got a graph that looks kind of similar to this graph. And then you're done with this step. So I'm going to go back to my report and just paste that graph in there. Okay, if the font ends up too small, there's a trick to getting it a little bit bigger, and that's if you just resize this graph to make the graph smaller. You'll notice that even though the graph size is smaller now, the font size has stayed the same. So it might look a bit nicer if we copy it like this instead. Get rid of this one, and we paste that in. So now all the writing is a bit bigger and a bit easier to see what's going on. Okay, so this is basically where I was hoping we'd get up to today. So just check that you've got there. Go back and just double check the steps. Obviously it's going to take a bit longer than it did for me, for you to do it, because you're kind of figuring out what you're doing as you go along. But once you've done all of this, you're kind of set and ready to launch into what we're going to be doing next time.